Hi scholars, so today we're completing Module 5, Lesson 21. So let's start with our learning intention. Thoughtful mathematicians recognize and show that equivalent fractions refer to the same points on the number line. So we can go ahead and pause and read these vocabulary words to yourself since we've been dealing with fractions for a few days, almost weeks now. And the same for these words, so go ahead and pause and read them to yourself. So before we get started, I want to point out that equivalent fraction is just a fancy way to say fractions that are equal to each other, right? And we're going to use these number lines to help us identify equivalent fractions. So we're actually practicing two skills, placing fractions on a number line and finding equivalent fractions using a number line. It says use the fractional units on the left to count up on the number line. Label the missing fractions on the blanks. So I don't have the fractional units on the left, but I'm just going to tell you what they are. I see that these are thirds on top, and on the bottom they're counting by sixths. So that's why this number line looks a little wonky, right? These dark marks are my thirds. And in between each mark, I have these dotted lines or dashed marks that represent the sixths, because sixths are half the size of thirds. They're a little bit smaller, right? So that's why they're in between each third. So I want to place these fractions, it says, by counting up on the number line. So I'll start with thirds. I have 0 thirds. After that, that would be 1 third, 2 thirds, 3 thirds, which is also 1 whole, 4 thirds, 5 thirds, and 6 thirds. So I'm going to do the same thing with my sixths. So I have 0, 1 sixth. This would be 2 sixths, 3 sixths. I want to fill this one in, 4 sixths. So I didn't fill in these because there was no line for me to fill in, so I didn't have to fill in that specific fraction. 4 sixths. This would be 5 sixths. 1 whole would be 6 sixths. 7 sixths, 8 sixths, 9 sixths, 10 sixths, 11 sixths, and 12 sixths. Kind of sounds like a tongue twister. So notice when I was counting up, my denominator did not change. For thirds, it stayed 3, and for sixths, it stayed at 6. But I changed the numerator every time I counted up. 0 thirds, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds. Same for sixth, 0 sixth, 1 sixth, 2 sixths, 3 sixths, 4 sixths, 5 sixths, 6 sixths, 7 sixths, 8 sixths, 9 sixths, 10 sixths, 11 sixths, and 12 sixths. So I want you to try one now. You're going to fill in these blanks by counting up on the number line. So I know it'd be a lot for you to draw this out, so I don't want you to draw them out, but I want you to write down the missing fractional parts that I would need to write in, right? So you can write in what fraction will go here, 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 and here, and the same for the eighths, because I know drawing this out would take a long time. So just write down the fractions that you would label. What would you label these missing parts? So go ahead and pause now and press play when you're ready. If you haven't already, please pause the video so that you can finish labeling these fractions. And we're going to go over our answers now. So here at the very beginning, you start with 0. I see this is 0 eighths, and the same is going to be true for fourths. 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, and 8 fourths. So let's look at the eighths now. I have 0 eighths, 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 8 eighths, 9 eighths, 10 eighths, 11 eighths, 12 eighths, 13 eighths, 14 eighths, 15 eighths, and 16 eighths. Again, notice I'm just counting up the way I would normally count, except I'm representing eighths instead of whole numbers. I don't change my denominator. All of these are all fourths, and all of these bottom here are all eighths. Again, notice I have my fourths as regular lines, but my eighths are represented using dotted lines because they're half of a fourth, right? 1/8 is half of 1/4. So I split in the middle. So now this is where we're actually going to use what we made on these number lines to help us find equivalent fractions. So I have my number line already filled in, right, that we did together in the previous slide. And I want to use it to help you compare 6/4 and 12 something. What would be equivalent to 6/4? How many eighths? Or what fraction would this actually be, right? I'm going to change my pen here. Okay, so 6/4, that's actually right here. So it didn't change to highlighter. There we go. So 6/4 is right here. I'm going to highlight this whole area. I see that 12/8 is on the same point as 6/4. So they are equivalent fractions. So 6/4 is equal to 12/8. Let's try one more together. So 1/4 and blank eighths. Let's find 1/4. Where's 1/4 on this number line? Right here. And what fraction is equivalent to 1/4? 2/8, right? I see it right under it. So go ahead and try this next one. Again, the number line has already been filled in for you. What fraction is equivalent to 2/3? So you can go ahead and pause and then find the equivalent fraction for 2/3. Again, pause now to find the equivalent fraction for 2/3. So 2/3 is right here. If I highlight this whole fraction up and down, I see that 4/6 is equivalent to 2/3. 4/6 and 2/3 are equal. They're on the same exact point on the number line. And try this last one. 6/3 is equivalent to what fraction? So again, pause now, find the equivalent fraction for 6/3, and then press play to check your work. So I see 6/3 is up here. If I look down, the equivalent fraction for 6/3 is 12/6. So to recap, first we were counting up on our number line by whatever fractional amount they told us, right? So in this case, on top of the number line, it was thirds, 0/3, 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. And on the bottom, we have 6, 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, and so on, right? We're counting by sixths. Very important. The numerator is changing as we count on, but the denominator stays the same. Then those points that repeated, right? So for thirds and 8 and 6, whatever point both fractions landed on, those fractions are equivalent. For example, 4/3 and 8/6 are equivalent. 6/3 and 12/6 that we just did right now are equivalent. They're equal to each other. Equivalent means equal. So similarly, you'll be placing or counting on a number line and then using those number lines to compare or find equivalent fractions in today's problem set. As always, you can reach out to me on Google Hangouts or Schoology if you have any questions. Thank you guys. Bye.